Part 2. I cannot believe the video just decided to cut off again. I don't know what happened this time. My memory was not full. This is very short. I'm almost done. Oh boy, it cut off right at that moment. Okay, same thing. Here are the problems you're going to do. All right, here we are. Back to this problem. I am sorry. I did the whole problem. I'm sitting there talking for a few minutes, and then I saw what. Okay, after you find the solubility of I, well, this is actually not the solubility of I negative. 1.5 10 to the negative 3 is X. So then iodide concentration will be 2 times X in the PbI2, which is 3.0 10 to the negative 3. X is 1.5 10 to the negative 3. So iodide is 2 times 1.5 10 to the negative 3, which is 3.0 10 to the negative 3 molar. So in a saturated lead iodide, or how about another way to put it, lead iodide will precipitate when iodide equals 3 times 10 to the negative 3. Copper 1 iodide will precipitate when it equals 2.3 10 to the negative 6. So I wrote the answer down here, and I was stating it, and I'll just keep it, I'll just state it again. So copper 1 iodide will precipitate first when iodide reaches 2.3 10 to the negative 6 molar. I didn't put an M there. See, think about this. This is a very small number, and that's a large number. Think of it this way. Say that you start off in a container. You had lead, Pb plus 2, and you had Cu plus 1. And you, drop by drop, you put in some iodide, little by little. Who is going to be the first one to make a solid? Well, every time you put a drop of iodide in, its molarity goes up, 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 more and more and more. I'm sorry, I shouldn't be touching this thing. I'm doing whatever. Sorry about that. I'm trying to hold the bottom part. Every time I put, there's no iodide to begin with. I put 1, 2, 3, 4. I put more and more. When the iodide gets to 2.3, 10 to the negative 6, that's a small number. When it gets to that, now you have solid CuI will form. But for lead 2, it's not going to form yet. It's not going to form until iodide gets to a bigger number, 3 times 10 to the negative 3 molar. So that's pretty much the answer, and I'll hold it back so you can write it down or just get a screenshot of it. Copper 1 iodide will precipitate, and I put first, when iodide reaches 2.3 10 to the negative 6. That is all you need to say. You don't need to say anything else. If you want to add it, later the lead 2 iodide precipitates when I negative equals 3 times 10 to the negative 3. So I wrote that in there too if you want. I'm sorry, I'm shaking it around because it's going at the bottom part. Okay. I was telling you there's another way you could do it, but I think it's probably, there might be an exception. There might be a time when that doesn't work. So I better not even tell you that. But I was going to just say that look at the solubility. Since that's a lower solubility than that is. That has a lower solubility in water than that does, right? Negative 6 and that. So a lower solubility means not as much is going to dissolve, so it will probably precipitate first. But you know, there could be an exception to that, to using that as a rule. Like if you had a common ion. Like if, just say if you had a lot of stuff, or some iodide was already present, but not enough. I don't know. So you know what? AP always... they prefer that you do it this way, so I would go with it as I'm showing you here. Do it the way I'm talking about right there. Do it the method I mentioned. When iodide reaches, look at the 2 iodide amounts, and whichever one reaches the smaller number, that will tell you as soon as the smaller number is reached, it's a solid. It precipitates first. Okay, wow. Okay, you guys, that is it. Finally, a lot of stuff. I'll see you.